So this is the 2016 Leave Insert Higher Level Paper 1, and we're looking at question number 2. Part A says find the range of values of x for which the modulus of x minus 4 is greater than or equal to 2, where x is an element of the set of real numbers. Okay, so the modulus of x minus 4, that means you take the positive value of whatever x minus 4 is. If the value of x minus 4 happened to be minus 3, you would take the value of 3. Or if it happened to be 3, you'd also take the value of 3. So, if you have an inequality with a modulus function involved, what you can do is square it. Because when you square something that's negative, it becomes positive. And when you square something that's positive, it remains positive. So what we can do here is square both sides. So what we end up with then is x minus 4 squared will be greater than or equal to 4 when we square both sides. And that gives us x minus 4 by itself greater than or equal to 4. And that gives us x squared minus 4x minus 4x, and minus 4 by minus 4 is positive 16, again greater than or equal to 4. So now we can tidy this up, bring the 4 over to this side, it becomes a negative 4. Bring this over here, it becomes minus 4. So we are left with x squared minus 4x gives us minus 8x, and 16 minus 4 is positive 12, and we know that's greater than or equal to 0 left on the right hand side. Okay, so now we have a quadratic trinomial on the left, so we can factorize this. Okay, so if we factorize this, we want factors of 12 that will add or subtract to give minus 8. Well, that's going to be minus 6 and minus 2. We want to know where that function is greater than or equal to 0. So if we can just imagine on the xy axis, there's our xy axis, this function would cross the x-axis at 6 and 2. So we can imagine that's 2. And this would be 6, and because the coefficient of x squared here is 1, which is positive, it would be a cup parabola rather than a cap, so it would be going down like this and up. Okay, so we want to know where is this function greater than or equal to 0. So it's going to be greater than or equal to 0, this part of the function here. So basically that's all the range of values of x would be the x values to the left of 2 and to the right of 6. They're the values we're looking at. So what we can say then is that x is less than or equal to, we keep the same, if it's greater than or equal to here, it's less than or equal to here. X is less than or equal to 2 in union with x is greater than or equal to 6. So that's everything to the right of 6 and everything to the left of 2. And that's the range of values of x for all values of x being part of the set of real numbers. So part B says solve the simultaneous equations. X squared plus xy plus 2y squared equals 4, and 2x plus 3y is equal to minus 1. Okay, so we can't solve these simultaneous equations by the elimination method, so we can use the substitution method. So the way we'll do that is with the easier equation, or with the linear equation, 2x plus 3y equals negative 1, we're going to express either x in terms of y or y in terms of x. So what I'm going to do is I'm going to move the 3y here over to this side. It becomes a negative 3y. So that leaves me with 2x is equal to minus 1 minus 3y. And if I divide both sides by 2, this leaves me on the left with x is equal to minus 1 minus 3y over 2. So I've expressed x in terms of y. So now what I'm going to do is I'm going to take this and I'm going to plug this into the other equation in place of x. I'm going to take that x, substitute in for both these x's this. Okay, so that's going to give me x squared, so that's going to be minus 1 minus 3y over 2 squared plus x times y, so it's going to be x again, which we now know is minus 1 minus 3y over 2. That's going to be multiplied by the y, and then we have our 2y squared is equal to 4. Okay, so first thing we're going to do is square this term, so that's going to be, just do this over to the side. If you square the top, when you're squaring a fraction, you're multiplying it by itself, so you're going to have minus 1 minus 3y over 2 by itself. So if we multiply the numerators, minus 1 by minus 1, positive 1, minus 3y by minus 1 is plus 3y. This minus 1 by that minus 3y is also plus 3y. And then minus 3y by minus 3y is positive 9y. So you can multiply in any order there, but you should end up with these 4 terms. That's the numerators done. And underneath we're multiplying 2 by 2, which gives me 4. So when I tidy this up, that's going to give me this was minus 3y by minus 3y was positive 9y squared. So when I tidy it up, I have 1 plus 6y plus 9y squared all over 4. So I have a quadratic trinomial on top expression all over 4. So that's going to give me, I'm going to replace this here then, just to be clear. This here has been done over here. So the answer is this. So I'm going to just have 1 plus 6y plus 9y squared all over 4 plus, I'm going to multiply this y now by each of these, so on top I'm going to have minus 1y, and the y by the minus 3y is minus 3y squared all over 2, and then I'm going to have plus 2y squared is equal to 4. Okay, so now it's beginning to get tidied up a bit. I want to get rid of the fractions now, so I'm going to multiply by the lowest common denominator of 4 and 2, which is 4. So I'm going to multiply every term by 4. So I'm just going to show this in a different colour. So I'll multiply this term by 4, this term by 4, this term by 4, and this term by 4. So when we do that, these 4's here cancel above and below, so I'm left with 1 plus 6y plus 9y squared. 2 into 2 goes once, 2 into 4 goes twice, so that's going to give me 2 times this, and then 2 times that. So 2 by minus 1y is minus 2y, and 2 by minus 3y squared is minus 6y squared. Here then, 4 by 2y squared gives me 8y squared. On the other side, 4 by 4 is 16. Okay, so what have we got now? We have, so now we're just going to tidy up the terms a bit. So we've got 9y squared minus 6y squared and plus 8y squared. So those three terms, 9 plus 8 is 17 minus 6, that's 11y squared. Then I've got my 6y minus 2y, so that's going to be 4y, positive 4y. And then I've got 1 here, and I'm going to bring this 16 over here to be a minus 16. So 1 minus 16 would be minus 15. And there'll be 0 left on the other side. So here's my quadratic equation that I'm now going to solve. So I can solve this either by factorizing or by quadratic formula. So you can use the quadratic formula minus b plus or minus the square root of b squared minus 4ac all over 2a. But I'm going to try and factorize it here. So I'm just going to, because 11 is prime, so I know I'm going to have 11y, and I'm going to have just y there. So now I'm trying to make this work here. So factors of minus 15. But I can kind of spot there if it's 15 and 11 will give me the 4. So I have a feeling that minus 15 and 1 could be the factors, even though it could be 3 and 5. But let's just try that. If I keep the 15 away from the 11, so if I had 15 here and 1 there, so then I'd have 11y and 15y, and to get 4y I'd want to subtract the 11y from that, so that could be minus and that could be plus, and that would work because positive 15 by minus 1 is minus 15, and 15y minus 11y is plus 4y. So now I can say that 11y plus 15, so if a bracket multiplied by a bracket is 0, well, I could do my split screen here and I could say either the first bracket is 0 or the second bracket is 0. So if the second bracket is 0, if y minus 1 is 0, well, y must be 1. There's one value of y. And if 11y plus 15 is 0, I'll bring the 15 over. Leaves me with 11y is equal to minus 15. So y would be equal to minus 15 over 11, dividing both sides by 11. That's my other value of y. Okay, so now that I have my values for y, I'm just going to substitute them into, well, it's easier to, I could substitute it in up here, but I'm actually just going to substitute it in here now. So if I take this down here, that gives me x is equal to minus 1 minus 3. Instead of y, I'll do this value first, so minus 3 by 1 all over 2. So that's going to be minus 1, minus 3 by 1 is minus 3, so that's minus 4 over 2. So my first value then, minus 4 over 2 is minus 2. So that's my x value. My first one, and then my other one is when I substitute the other y value into the same equation. So x is equal to minus 1 minus 3 by minus 15 over 11. And then that's all over 2. So I'm just going to put all of this into the calculator. And that's leaving me with 17 over 11. So there's my two y values and my two x values. So I've solved the simultaneous equation, and that's the end of part B and the question.